Alright, time for another draftphysics.com. Debatephysics.com also, but again, the debate is just a mess. So, can't be done in any kind of reasonable manner where, statements are made and then there's evidence and then there's, arguments maybe about the evidence. And one of the arguments that should never take place is some argument where people defend the absence of evidence and say, well, we could believe anyway. We can assert that one theory is better than another because there's somehow we believe it is, and you don't have to show that it is. Something like that anyway. What is all this fuzziness? Who knows? Anyway, so the Ian Gosling experiment. I mean, it's just, after all these, this is years of this, right? And they still just pull all this shenanigan bullshit. I mean, this one, I don't know if it's deliberate or what it is, but it's just so damn stupid. So he never measured the weights of the masses because he says he doesn't have a scale that can measure these masses. And so he was just guessing at the ratio. Now, I found by his dimensions that the ratio is barely 2 to 1. It's a little bit over 2 to 1. Now, I got to say that his measurement must suck because it doesn't look that way. But anyway, so I mean, I got numbers of 25 to 55 would be the ratio. So clearly it's a little over twice as heavy, not almost 3 times as heavy. So of course, it didn't go back half the velocity and blah, 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 blah. Which we would agree on. Again, it's not so much, the argument isn't so much about what's going one way, it's about what's going the other way. But anyway, so something to remember that, I hadn't remembered is that pendulums swing at the same period no matter what the velocity. So no matter how fast, how high I make it or how small it is, it's the same period. So theoretically, all mass differentials should hit at the bottom, because they should, no matter how fast or slow they're going, they should take the same exact time to do whatever they're doing and get back to the center again. So obviously in his experiment it wasn't really centered, so it gets off. But Newton's cradles do the same thing, where they're just not making perfect enough exchanges for the period to stay, for the center to stay right in the center. There's always a little residual velocity left in after the collision. Something doesn't perfectly stop kind of argument. Or it stops in a position where it's going to fall. So, because they're not hitting it exactly the right place. Well, anyway, but the point is no matter what experiment you do, it would appear, that there's a symmetry. But obviously one thing is moving less than the other thing is moving. It just appears, if you look from the center, like, they're sort of going the same. Even though one's going more distance than the other, blah, 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 and one's going a faster speed, they're going to return at the same time. All right, so that's the key thing to note. So, I guess I'll just go to the drawing and attempt to explain again what I'm saying, and my argument versus their argument. And I guess clearly what's got to be stated is we're arguing. This has to go this way. Whoa. It's a bit messy. Sorry. You don't even need this part. This was from the previous conversation. These were just notes I took. So the idea is what I'm saying. Obviously, when they're the same mass. Damn it. I don't want to get another crayon. Fuck. Well, this old one seems to be working well enough. We'll go with it. all right, so when they're the same mass, I mean, you have 100% here, goes in, 100% comes out, okay? And the idea is as you make this heavier, you're going to get less than 100%. And so in the 2-to-1 case, 66% of the momentum will go this way, all right, and 33% will go this way. Now, this way, 33% of the same mass object means 33% of the velocity. So 1/3 the velocity is what you'd expect. Now, that seems pretty close to what he got in the experiment. A little bit more than that, right? So it's perfectly consistent with that ratio. And the thing we don't know is the bigger mass just going this lesser velocity. But the thing is, with the 1-to-2 ratio, it's the same velocity. So it is 1/3 the velocity. Okay. So they do move from each other at the same rate with the 1-to-2 mass. And then if you go to 1-to-3 is where it gets interesting. Because they say, and I say, okay, yes, 50% comes back this way. 50% of the velocity. All right, and only 50% of the momentum's going this way, though. So 50% of the momentum goes this way, 50% of the momentum goes that way. And because it's a 3 mass, you end up with a velocity of 0.16, whatever, 5. Okay, so yes, this velocity is going to be much slower than this velocity. Because this is a 3 mass and it's only got half the energy. And then when you go to a 4 mass, you get an even smaller number, of velocity this way, and a 5 mass, even less velocity, until you get to a 6 or 7 mass, where this number will go from 50% to 66%, and then it'll be, I think that's where we stop at 66, and then we go to 100. So this would be 100 in reflection, and nothing going this way. And so that's my argument, is you have to conserve the momentum. And the fact is all you have is 100, and you have to spread the 100 over all the objects in the experiment, and you can't make more momentum. And obviously, if you're going to say that this does go with 200%, okay, of the original, like at the 3 mass, they're saying it's 150% of the original momentum goes off this way. And obviously, if it's coming back, then you have a 200 against a 100 for a 300 total in a car crash. And if a 300 total goes into a car crash, more than 100 is coming out. All right. So that's why I say it doesn't make any sense. Can't make any sense, their theory. But anyway, so this experiment is kind of useless because these numbers aren't under dispute, theoretically. I mean, they certainly weren't disputed by the video, which basically showed exactly that happening. And so the experiment we really do need is the 1-to-3, because that's when they really start making a significant amount of momentum in the forward direction. So it's not so much about the reflection, it's about what's going forward. And it's not accurate to say that 50% of the energy goes one way and 50% goes the other way, because clearly in the end they're going to say 200% went this way, so it's never 50-50. All right. That's probably enough of that. So, so why? I mean, he should have known he really has to measure the weights of the objects. I mean, damn it. Come on. You got to get that right. It's essential to what you can predict what's going to happen. It's going to change depending on the masses. You don't have that right, then you don't have an experiment that's going to have any value. Shit. I shouldn't have to explain that. Alright, so we might as well do this comment. So this was basically about black holes, so it's really not the same subject, but who cares? No need to make a separate video, really. Anyway. All right, so he's asked a couple of questions. I think I answered them. I don't have any animosity. I'm just frustrated and sick of the fact that, this is so fucking simple. The idea that a force is collected by objects, that the force is quantizable because it's in little frickin' elements. This is not complicated, and the force just represents momentum. It's a mass and a velocity, and all you can do is collect a mass. If your mass crashes into another mass and you become a new collection moving, you have to divide the velocity by the increase in the mass. I mean, it's not that complicated, but you always conserve the momentum. All right. First of all, let me thank you for being so responsive to taking the time to go through the comments. However, there's no need to get too mean or condescending. Well, I'm sorry, you're saying there's no need. I've been doing this for 10 fucking years, and frankly, if people aren't in direct pervert, duplicitous hypocrisy mode, they're in, feigning some sort of ignorance, that I can't believe, it's so deep in terms of what I have to explain to you, how there is no evidence. I have to explain over and over again how Eddington was a shitty experiment, how every other experiment that confirms isn't exactly the same. It's a very different experiment because scatter can be the explanation. I mean, all these things I've had to go over and over and over again. And in all that time, I can't say there's been 2 comments in 10 years saying something like, shit, we ought to be arguing with physics and asking them to do these experiments. It's disgusting that they haven't proven any of this shit. They haven't proven that 4 pounds dropped 1 fucking foot is the same energy as 1 pound dropped 4 feet. They've had 300 fucking years to do an experiment that simple. Even the car crash thing, fuck this, is such bullshit. They say it's 16 times the fuel to spin a motor 4 times as fast. Well, fuck, prove it. And nobody can say these words. Fuck this. It's ridiculous. Physics isn't a science. It's a fucking religion. Obviously, they don't give a fuck about evidence. They just tell their fucking stories. They're mathematical stories. Oh, fuck. Pauli exclusion principle. I have to explain to you how ludicrous it is that they're arguing that electrons and protons can occupy exactly the same space. I have to explain why that doesn't make much sense. Anyway, especially since I am a frequent viewer and I admire your dedication. I mean, all that doesn't mean anything to me, frankly. I'm very happy, fine, thank you, great. I'm glad one person, you know what it feels like to say, oh, gee, there's one person that can get a little bit of this. And I would argue you can only get a little bit of it when you're sitting there throwing extra twos on my formula, right? I tell you it's 2 + 2 + 2 physics. I'm telling you it's 2 + 2 + 2 physics. It's not 2 + 2 + 2 + 2. There's no other fucking 2. God damn it. Anyway. Logic and countless hours of thought and work. Yes, it is countless. It's a fucking decade of my fucking goddamn life. And it's been the most depressing and discouraging thing that's happened in my entire life, is to realize people are fucking so goddamn stupid that there's no point in talking to them. Alright, anyway. Let me clarify my previous comment. You ought to just say you were drunk. Just tell me you were drunk. Sorry. Won't do it again. About the quantized space. There's no point. There's no need for any of it. You have stuff moving. The force is moving the speed of light. You don't need to quantize its motion. It's completely irrelevant. It has momentum. Okay, you don't need to quantize it. It already is in the form of a mass and a velocity. It's already all you need to know. It's a minimum amount of momentum. The smallest amount of momentum in the universe is a quantum of force. That got you somewhat upset. What got me upset is you telling me my theory needs something else in it, when no, it doesn't. Electrons, protons, and force bits works just fucking fine. It covers it all. Alright, in your push universe model, all matter particles get pushed towards each other by the force bits. Yes, the force bits don't get pushed anywhere because they're already fucking moving and they don't interact in any way you could notice. Then the closer a proton gets to another proton, so again, it can't get very close to another proton or electron, the more they push each other away. Yes, and that's because of the one part I'll concede needs, the last two could be a 3. One of the interactions, the possible interactions, is when an electron force goes into a proton, it comes out an electron force. So obviously you can understand, okay, that the proton, what did I say? It comes out of proton force. Right, so you can understand that if a proton force goes into an electron and it's turned into an electron force, then the electrons are going to see twice as much force when they see each other, because all the red force was turned into blue force. Then the closer the proton gets to another proton or electron, the more they push each other away. Yes, so they don't touch. Of course, they don't touch each other. What's it just? Then the closer the proton gets to another proton, you don't understand. Those two things don't get close to each other. What gets close to each other is the electron and the proton. The things with attraction. So they don't touch. Okay, that works for E negative E and P negative P. Well, okay, I guess that's electron on electron, proton on proton. Okay. However, your theory does not explain why there's a PE limit. Where did I say there was a PE limit? Where? Oh, that's right. I've never said anything about some limit. Okay, and the argument basically is that when you put them, rotation is what really hurts them. So if you understand that electrons and protons are dragged by the field, that is, you can't shoot a single electron through space and get it to go anywhere because it drags to a halt. The same for a proton by itself. So you have to have things that are proton, electron, proton for it to keep going. It has to be a stable engine. It can't just be loose particles, loose bits. So you can understand, let's say if a neutron is inside a nucleus and it's stabilized, that is, it can't rotate, then it has no angular momentum. That means it has no, the electrons and the protons aren't moving, much. They could be jiggling, but they're not moving in a direction. So they can't be dragged to a halt. But as soon as it gets out into the real world and it can start spinning, you can understand that with each rotation, it starts to take its energy away. And that would mean it would take away the energy that's also holding it together. So there would be a shearing force when neutrons are in free space. They end up turning into something like a hydrogen atom. They end up not being able to get very close to each other because they're always constantly rotating around each other, but they can never do it very fast because as soon as they gain some velocity, it's dragged out of them. So they're constantly losing energy to the system they're hitting. see how else to say it. I don't need to say it some other way. I'm just saying those velocities will tend to pull them apart. So once they're together, it's easy for them to stay together. But put them in free space and start to move them a little bit of separation, and then they start moving, they start falling apart. All right, anyway. Okay, so, however, your theory does not explain why there's a PE limit. So I didn't say there was a limit. Okay, in your theory, the red and blue force quanta can occupy the same space. Fuck you. I never, where would I say anything like that? In your theory, the red and blue force quanta can occupy the same space. Fuck you. Where did I say anything like that? Where? I'm just saying, see, this is what pisses me off. In what drawing could you find that interpretation? I mean, in what video did I give you that impression when I sit there and draw it? It's in the background of this video. There's little stuff. Do you see any of those little bits occupying the same fucking space? They really don't do that. Okay, yes, they travel past each other. But I always drawing it with bits and locations, moving vectors, moving directions, always. Nothing's in the same space. Shit. All right. Yet the P and E particles cannot. So again, it's just so... I don't know. There's just any point. The force bits, you could argue the force bits are, in two separate dimensions, right? So let's just say the red bits can never hit a blue bit because it's two checkerboards that are not even, that they don't intersect anywhere. All right. And what matter makes it possible for them to intersect. But the rest, the rest of the blue bits, it's just a kinetic interaction. If two of them hit each other this way, what's going to be the outcome? Well, they're both going to end up just doing the opposite. This one's going to go this way, and this one's going to go that way. So the universe will look. How would the universe look if they didn't hit each other? Oh, that's right. It would look like one going this way and one going that way. Well, that's exactly what you end up when they hit each other. You see, so the universe can't change. The force can't make anything change because the outcomes will be the same whether they hit each other or they don't hit each other. The universe looks exactly the same. And the only thing you have to account for is the fact that the proton force would make a difference. If these were red, these were protons, then you would have a difference because the exchange would mean that the X force is going this way when the X force was going that way and the vice versa. So there would be a change. But the simple truth is, I never even made a video where I ever talked about anything occupying the same space. It's just, what the fuck are you talking about? Things can't occupy the same space. They can't be in the same place at the same fucking time. Oh, god damn it. Occupy the same space, but you do not explain what finally keeps them apart. Well, fuck you. In standard physics, it's the electromagnetic force. So that's a made-up word. The electromagnetic, the electrodynamic force, he called it. So what is that? Yeah, well, right. I mean, the strong force is what they argue is holding the nucleus together. The made-up fake force that just disappears. It isn't accountable to the universe. You can apply it and then it just disappears. Space quanta, whatever. Obviously, I have no use for what conventional physics says. They just make it up. There's no fucking evidence that it exists. They're saying it must exist because it's the only way protons can get close to each other. Obviously, I'm pointed out how it's really easy for protons to get close to each other if you just stick an electron between them. I hate this shit. So why are you bringing up the Pauli exclusion principle? Where the fuck did where did anything rational be written about the Pauli exclusion principle? Show me the piece of evidence that says I have to believe this crap. That this has anything to do with reality. Oh, fuck. Discrete orbits, etc. It's just so fucking stupid. Orbits. Orbits are really complicated, okay? I mean, it's really... you can't get into an orbit unless, in our physical solar system, unless something changes your speed. So you can't make something, you can't throw something into a solar system where it hits nothing and it goes into an orbit. You just can't do it. It's impossible. So what's the likelihood that you could create orbits, in nuclear space with objects that are identical? That is, all the electrons have an identical mass. I mean, how could you possibly give them just the right velocities? I mean, it's all too silly. The orbiting model of the atom is shit. Again, it's something for which there's no evidence. They just made up their guess. It's their shitty guess. And I don't know why, why is this the only guess talked about? And why is this such a great guess that we all have to exclude every other possible explanation? I mean, I think the very fact that atomic bonds work means that there can't be orbits. How can you share an electron that is gone 90% of the time? It's not where you need it to be. 90% of the time, it's not where you need it to be. How can you share something that you don't have, but, whatever, 0.03% of the time? Oh, fuck. So you're just going to keep arguing this shit, and it's just nothing. If I haven't said it, I haven't implied it, and then you're saying, well, why are you pissed off? I mean, I'm completely perverting what you said. Isn't that, just fine? So he says here, what keeps PE apart in your theory? Nothing keeps it apart except the fact that there's so much activity in the universe. It's like magnets. Magnets only work when they can see each other, right? You start moving them up and down, all of a sudden the attraction force breaks down. They don't work as good, right? Because you're mixing the forces. So the same thing happens to electrons and protons when they're free, is that they're moving not necessarily in only one direction. They're moving in different directions based on whatever the field is at the time. They're jittering at a different rate. And so that constant jittering means that they can't have perfect alignment with each other. So they can't stick perfectly together. All right, what keeps PE apart in your theory despite being constantly pushed towards each other? The heat of the universe. The very fact that it's jittering, which means it's more jitter on the outside than there is in the nucleus. In the nucleus, there's less jitter because there's so much density of objects, that you dampen the jitter. Okay, if one super accelerated, oh fuck the U, electron crashed into a P, right? Yeah. So, yes, exactly. So if it crashed into it, that would mean that it can't combine. So that's just like saying, again, if I made magnetic monopoles, if you could imagine a magnetic monopole, and I made magnetic monopoles, you could understand that, yes, if you go in too fast, they'll hit each other. There'll be some sort of elastic exchange of momentum, and they'll probably just fly apart. They won't stay stuck together. So it just depends on how hard you hit them into each other. Okay, what exactly happens that moment that prevents overlap? So there's no overlap. It's hard shit, okay? Just like us. I mean, obviously, the hardness of us has to be built out of something. It really doesn't matter because you can make them infinitesimally small and just based on the force. And you could argue that the force, they couldn't have a charge density. So this, I guess, would be the thing to recognize, right? You need a certain surface size to produce a certain charge density. I'm just trying to think of how you could do this without having a size to electrons and protons. No, you really do need a size. They have to have a size. And so this overlap thing is just... I mean, if you don't use size, then you never have an end to their movement towards each other, and it's some sort of infinite trap. And I say, well, that obviously isn't conducive to any kind of stability, and it would mean there would have to be some sort of infinite speed. So they would have to move towards each other at the speed of light forever. You know, the infinitesimal particle. So, you know, I don't want to get into this splitting tortoise fucking half the path kind of Zulu's paradox kind of bullshit. I mean, why get into all that shit? Why can't we just say that whatever it is, a millionth of a millimeter, okay? An electron is a millionth of a millimeter across. And that's how it's, and you can recognize that's the size of the light bulb, and the photons are coming off of that surface. You know, and the proton has to be the same size, even though it's a greater mass. It's the same size because it has the same charge profile. All right, when you claim that a proton can push an electron away, when did I ever claim that? When you claim that a proton can push an electron away, so I never claimed that. I've never made a video about a proton-electron interaction where the proton is pushed away or the electron is pushed away. I've never said it ever. Okay. As can be seen by your simulation software. So that doesn't happen. If you see it in the simulation, it's clearly a defect of the fact that the simulation is a two-dimensional simulation that is trying to duplicate a field that is a billion times more dense than I can simulate. So, you know, that's just an artifact of time. You're watching something that's taking place on a level of 1/trillionth or gazillionth of a second in the real atomic universe. And, but yes, no, electrons don't repel protons. All right. You seem to have introduced another push force, which is realized not by your red-blue force quanta, but by something else. Obviously, the environment introduces it. So if there's another electron here, and there's an electron here, and there's a proton here, the two electrons are going to interact with each other and create forces of repulsion that could make it look like this electron was running from the proton, when no, it's running from the electron. But yeah, I don't know, you know, again, you're just... I wish you would quote a piece of my video where I gave any impression that electrons ever repel protons, because they don't. But if they're in a mixed field, you know, I mean, I've drawn this example hundreds of times. Shit. It's just so tedious. Let's see, you can see this, right? No, you can't. So I drew that shit before and you couldn't see it. Aha, I knew. Alright. Get rid of this stupid thing. So the kinetic thing was really simple. Okay, so I won't go over it again. Anyway. Alright, so look, here's so you have a nucleus that's not positive. I should have drawn it red, of course. Alright, it's net positive. It has more protons in it than electrons if you count the neutrons as being a pair. Okay. And then you have this extra capacity for electrons to be collected with a lesser amount of force. I mean, it's positive, but it's got hunks of negative in it, right? So we know that in places it's going to look negative because of the electrons. Okay, and in other places it's going to look positive because of the protons. And the net is that it's more positive than negative. All right, so what does an electron see? So an electron sitting here. Well, obviously it sees the proton, says, yes, me wanty. Okay, especially coming from this direction, let's just say. Okay. All right, it's going to say, yes, I see this. Okay, we see each other as having almost no force between us, right? I mean, all the red force coming this way has been turned into blue force. All the blue force coming this way has been turned into red force. So there's no force here between them. There's lots of blue force pushing this. There's lots of red force pushing that. Nothing in between them. So obviously it wants to go this way. But what's going to happen as it's going this way? Well, all of a sudden it's going to start seeing this blue force and this blue force. Right? That's what's going to stop it from crashing into the proton. So that's what's going to make the electron have to settle for a position here. Some distance. So, electron here, some distance. Electron here, some distance. Electron here, some distance. Electron here, some distance, right? And then you can go a step further. You can say, well, look, there's 2 protons here and only 1 electron here. So, an electron here, okay, let's see this inviting forces applied here. And this is only 1/2 of that, and this is only some 1/4 of that because of the distance. So now this would be another position where an electron could settle. You see what's happening? You know, you're automatically creating the energy levels. All right, and you have to do this now in 3 dimensions, of course. So you can really understand how this isn't that complicated, right? And then when something's sharing electrons, when atoms are sharing, they could be sharing 2 of these, right? And then I can build a whole nother atom over here, and they're physically sharing them. Because when you break them apart, you end up with an ion. You end up with one that's missing. You know, one ends up having the electron, taking it. The other one ends up losing it. Yeah, it's not complicated, really. But there's no... If all that was in the universe was 1 red and 1 blue, yeah, they're going to crash right into each other, and there's going to be a neutron there. But again, the neutron is getting hit by all kinds of force. So at one moment, the blue goes this way, and the next moment, the red goes that way. You can see that there's tension being created because of the fact that they're moving in other directions, because the universe is tugging them and vibrating them in all the directions. So it's hard for them to stay next to each other because they're being pushed independently. Especially if there's an electron here that's pushing electron force, because it's going to move this one this way, and it's going to move the proton they're going to move it in opposite directions. So any charge differential in the field means that the pieces of the neutron are going to be separately tugged. One piece is going to be tugged one way, and the other piece is going to be tugged the other way. So there's just an obvious reason to think there's going to be something pulling them apart. I mean, if a regular magnet with a north and south pole, if you could just understand that as a monopole, and that the positive side is really independent of the negative side, and that then when I put it in a charge field, it won't only just turn, but the part that is being repelled will move away, and the part that wants to go towards will move towards. The two will separate from each other. Now, obviously, they have to do that against their attractive force, but I'm just saying if the charge field is strong enough, it's going to pull the two apart because they're not bound magnetically. Charge isn't an infinite force, and the field is applying a force differential. You can't find a piece of space, say, okay, this piece of space right here, the charge is exactly the same from all locations. So no matter which way I look, it would be exactly the same charge. Obviously, you couldn't make such a place in space. Just as you can't make a place in space that's getting hit with the same number of photons from all directions. There's no such place in space. So obviously there's going to be a lot of tension placed on a neutron in emptier space. The more empty the space, the more empty is the wrong way to say it. I mean, if I can make it perfectly empty, obviously there'd be no tension and the neutron will be just fine. But obviously there's going to be differences. There's going to be more blue light coming from that direction and more red light coming from that direction. There's going to be forces pulling those two things, pushing on those two things in opposite directions. All right, it's probably enough. That's more than enough. But look, it's nothing personal, and I have zero patience. Because I've been doing this so long, and everybody's an imbecile. I'm sorry. Some of this just sounds imbecilic because I never said any of this shit. And it just looks like you're, looking for bullshit. I never stated the simulation was complete. But it does what it's supposed to. I mean, the electrons and protons combine, and the electrons repel the electrons, and the protons repel the protons. So it works fine. I don't know what kind of little piece of crud you pulled out of that to turn it into something that wasn't working. Well, whatever. There's just no point. There's just no communication with people. I mean, you give them the simple answer and they just keep trying to turn it into something more complicated. It's not complicated. I don't know what to metaphor it to. I mean, somebody can give you a preposterously silly, gremlin, hobgoblin explanation for why a geyser, shoots, at this regular time intervals. And then somebody can just give you the simple explanation that it shoots the water out, cold water fills the vessel, the water takes a while to heat, it builds up pressure, and it shoots. I mean, so, it's just about the fact that it always blows the same amount of water. And then it has to heat the same amount of water. And that takes the same amount of time. But anyway. Till the next time and such and so forth and whatnot.